Problem 2. A saturated solution of magnesium sulfate at 80 degrees Celsius is cooled to 30 degrees Celsius. During the process of cooling, 4% of original water is lost. Find the weight of feed needed to crystallize 9193 kg of magnesium sulfate .7H2O. And as a data, solubility value at 30 degrees Celsius and 80 degrees Celsius is given. Let's start solving the problem. We know that the first step is to draw the schematic. As per the question, the feed is at 80 degrees Celsius, so I have mentioned there. And the product should be at 30 degrees Celsius. It is important because the solubility data is given with respect to temperature. Hence, we have to use the respective solubility data based on the temperature. Let's fill the schematic with the given data. Let's read the third line. Find the weight of feed. So we are asked to find the feed, which is M1, needed to crystallize 9193 kg of magnesium sulfate .7H2O. So here the crystal mass is given, hence M4 value is given. Hence I am filling M4 as 9193 kg. Now the solubility at 80 degrees Celsius is given as 64.2 MgSO₄ per 100 gram of water. Using this solubility value, we have to identify the mass percentage. This table will help us to do this process. From the solubility value, we know that the solution contains 64.2 gram of magnesium sulfate in every 100 gram of water. Hence, the mass of magnesium sulfate is 64.2. The mass of water is 100 gram. Now, from this value, we can find the mass percentage by finding the total mass. The total mass is 164.2 kg. To find the mass percentage, we have to find the ratio of individual mass by total mass. So in case of magnesium sulfate, 64.2 divided by 164.2 kg, which is the total mass, which gives us 0.39. Similarly, we do for water, which comes to be 0.61. When we multiply this value by 100, we get the mass percentage. Now as it is in mass fraction. Now I can fill this value in this feed table because it is at 80 degrees Celsius. Now the solid percentage is 0.39 and the water percentage is 0.61. Now let's use the solubility data given at 30 degrees Celsius. So the magnesium sulfate is 40.8 gram, water is 100 gram. The total mass would be 140.8 grams. We can find the mass percentage by finding the ratio of individual mass by total mass. In case of magnesium sulfate, it is 40.8 divided by 140.8, which equals 0.29. Similarly, we do for water, 100 gram by 140.8 gram, which gives us 0.71. As I already told you, this is mass fraction value. If we multiply by 100, we get mass percentage. Let me fill the mass fraction value in the table. So we fill the value in the table. Solid fraction is 0.29. Water fraction is 0.71. Now we have find the solid water composition in feed and mother liquor stream. Let me move on to the next stream. So water evaporated stream. The question says during the process of cooling, 4% of original water is lost, which can be mathematically said by M2 is equal to 4% of water in the feed. Do we know the water in the feed? We don't know. But we know how much percentage of M1 is water. So as per the value we just found using solubility data, there were 61% of M1 is water. Hence I am written here 61% of M1 is water. By solving, we can find an expression for M2 which comes to be 0.0241 times M1. I am filling the table with the respective value here. So M2 is equal to 0.0241 times M1. M1 value we don't know as of now, but once we calculate it, we can replace the value of M1 here in this expression and we can calculate M2. Now we will move on to the fourth stream, M4. The details of M4 can be taken from this particular molecular formula, MgSO₄ the same way we did for the previous problem 1. So from the moles, we can find the mass and so the mass percentage. Every crystal comprises of 1 mole of magnesium sulfate and 7 moles of water. By using the atomic weight, we can calculate the molecular weight of MgSO₄ and 7 times water, which comes to be 120.37 for MgSO₄, and the mass of 7 moles of water comes to be 126. Now we have found the total mass, which comes to be 246.37 kg. Now we know the mass of magnesium sulfate and water in 1 mole of MgSO4.7H2O. Now we can convert this mass into mass fraction. The mass fraction of each component can be found by finding the ratio of mass by total mass. In case of MgSO4, the mass is 120.37 and the total mass is 246.37. So the ratio comes to be 0.49. In case of water, it is 126 by 246.37, which comes to be 0.51. Now I can take this value and fill in this table. Hence we found the solid and water percentage in each streams here. Now we can move on to solve the three major equations, that is overall mass balance equation, solid balance equation and water balance equation. We know that how we return this solid and water balance equation, that is by multiplying with the respective solid or water percentage with the mass of the respective stream. Moving forward, I am replacing M2 by this particular expression which we found by incorporating the details of water lost as vapor, which is equal to 0.0241 times M1. Now we write the solid balance equation. We know the value of solid fraction in each stream. Hence, M1 is multiplied by the respective solid fraction. M2, we know already it's replaced by 0.0241 times M1. The M2, the solid percentage is 0. Hence, we are multiplying with 0. In case of M3, the solid percentage is 0.29. Hence, we are multiplying the M3 stream with 0.29 and similarly for M4 by 0.49. Now we can write similarly for water balance equation where we multiply the mass of each stream by its respective water percentage. So M1, the water percentage is 0.61. So we are multiplying the mass M1 by 0.61 and we do the same for M2, M3 and M4. In case of M2, we replaced M2 by 0.0241 times M1, but the water percentage is M2 is equal to 100%, so hence we are multiplying with the fraction 1 value here and we got this equation. Now we simplify this three equation to obtain a set of equations with only two unknown variables. So let's simplify one by one. In the overall mass balance equation, we know M1 and M2 value. So let's replace those respective values. In case of overall mass balance equation, two terms have M1. So hence I am combining M1 terms to one side of the equation and remaining in the other side of the equation. So M3 plus M4 is equal to M1 minus 0.0241 times M1, which comes to be 0.976 times M1. So the overall mass balance equation comes to be 0.972 times M1 minus M3 minus M4 is equal to 0. The solid balance equation, as we are multiplying the first term in the right hand side by 0, so the first term will not be there. So remaining can be written as an equation which is 0.39 times M1, which is equal to 0.29 times M3 plus 0.49 times M4. Now we'll move on to water balance equation. In water balance equation, we get 0.61 times M1, which is equal to 0.0241 times M1 plus 0.71 times M3 plus 0.51 times M4. Now we got this three simplified equation. Let's try to solve this equation to get the answer. We can use the calculator to solve these three equations. In exam point of view, we don't have time to solve this equation manually. I have used the calculator method to calculate M1, M2, M3 and M4 here.